Okay, so since we have been working on solving systems by graphing, today we're going to look at our second method of solving systems. We're going to use something called substitution. So in order to solve systems by substitution, you need to solve one of your equations for x or y, meaning that you want to get x or y by itself. So like y equals 2x minus 3 or x equals 6y plus 1. Just get one of them alone on that left-hand side. Then we're going to substitute this into the other equation. So like if we have y equals 2x minus 3, since it's equal, I can plug that whole 2x minus 3 in for y in the other equation. You're going to solve for the variable that's left and then plug your answer for that variable into the other one of the other equations. So we're going to look at an example. So I have y equals 7x plus 5 and y equals 8x plus 6. My goal is to find out what ordered pair again, xy, is going to make both of these true. So this is different than graphing. These clearly you would know how to graph. But since I'm told y equals 8x plus 6, I can replace this y with that 8x plus 6 because they are equal. So I'm going to do 8x plus 6 equals 7x plus 5. Well, now this is an equation that we know how to solve, so we want to get our variables to one side and our constants to the other. So I'm going to subtract 7x. We get 1x plus 6 equals 5, and subtract 6. So we get that x equals negative 1. So now I can take that x equals negative 1, so you might think you're done, but you still need your y value. So now I can take this negative 1 and plug it into x for one of my variables that are solved for y. You would get the same answer no matter which one you use. So we're going to do 7 times negative 1 plus 5. We get negative 7 plus 5, so y equals negative 2. So the solution that makes this true is negative 1, negative 2. Now sometimes you might not have them where they both equal y, but in this case, one of them is set equal, that y is by itself. So I know y equals 4x minus 23. So in this equation, I'm going to replace y with 4x minus 23. So we have 4x plus 6 times y. So instead of y, we have 6 times 4x minus 23 equals 2. Now it's an equation that we know how to solve. So we're going to start off by distributing. So we have 4x plus 24x minus 23 times 6 gives us minus 138 equals 2. So I'm going to combine my like terms on this side and add 138 to the other side. So we're left with 28x equals 140. And your last step is to divide by 28. So we're going to get that x equals 5. But again, we're not done. We need to take this x equals 5. And we already have y equals 4x minus 23. So I'm going to plug it into that equation, the one with my variable by itself. So we have y equals 4 times x, but we know x is 5 minus 23. So we have 20 minus 23 gives us negative 3. So our solution that makes this equation true is 5, negative 3. So now we have the same thing again. We have one of our variables solved for, so it doesn't always have to be y. It can be the x that is solved for as well. You would just plug it in for x in the other equation. So I'm going to take this 6x plus 6. It's equal to y, so I can replace the y with it here. So we have 12x minus 2 times 6x plus 6 equals negative 7. I'm going to distribute in my negative 2. So we have 12x minus 12 equals negative 7. So now this one is one of our special cases. So we have 12x minus 12x, that goes away, that's 0. We're left with negative 12 equals negative 7. Since negative 12 does not equal negative 7, this is one that is no solution. So this would be the one that would be parallel when we're graphing. They're never going to meet, so they're never going to have a point where both equations are true. That's because this negative 12 does not equal negative 7. If you do all this and your variables cancel out and you're left with 7 equals 7, 2 equals 2, 0 equals 0, those are all true, so those would give you your infinite solutions. But your variables have to cancel out for this to happen. Our last example is one where one of our variables is not by itself. So we want to try to make one of our variables get by itself. So I think it looks easiest in this one to get the x by itself because it's already it has a coefficient of 1, we won't have to divide anything. So I'm going to do it off to the side here. To get that x by itself, I'm going to add 6y to both sides. So now I have x equals positive 6y minus 12. Now that x is by itself. So now I'm going to plug that whole thing in for x in this other equation. So you could solve for either variable, but it's always easiest to solve for the one that doesn't have a coefficient. So we're going to have 4 times 6y minus 12 plus 5y equals negative 19. And we're going to solve this equation. So we get 24y minus 48 plus 5y equals negative 19. I'm going to add 48 to both sides and combine my like terms. So we get 29y equals 29, so y equals 1. Whoops. So we get y equals 1. Now I'm going to plug that in to my equation where I solved for the variable because then it's easy to find out what x is. So we get 6 times 1 minus 12 gives us negative 6. So our answer to make both of these equations true would be negative 6, 1. So we're going to work on solving these in class tomorrow, so make sure you come to class with any questions you have.